I'm Sampath, and I'm going to talk about how a robot can interface with MIDCA. More specifically, what is interface with MIDCA. I'm going to show you it. Now let's get started. Everybody here had talked a lot about the cognitive architecture MIDCA, so I'm not going deep into the architecture and I'm not going to talk about it. But what I'm going to do is show MIDCA in action, applied to the blocks world domain through Baxter robot. Whoever who don't know what a Baxter robot is, I'm going to introduce it to you and talk a few things about ROS and finally show you what Baxter robot can do in a blocks world domain with ROS. So let's get started on the abstraction of how a robot can interface with MIDCA. Let's get this image. So this is the bottom part of which is MIDCA. It's going to interface it through to the robot through ROS, and these are the ROS buffers which instantiate the communication. And here goes a simulator uh, for whoever who doesn't have a Baxter robot or a kind of robot of its kind. We can use the simulator. So let's see what a Baxter robot is. Baxter robot is manufactured by Rethink Robotics. It's mainly used in manufacturing industries, and there are different kinds of Baxter robot. The one which we use is a research robot, and it contains a screen and three cameras, one on the right hand, one on the left hand, and one on its screen. And moreover, it contains seven Baxter's arms contains 7 degrees of freedom, and the sonar ring on its top is actually to detect the objects of its size. So what are we expecting from Baxter and MIDCA? Should perceive the world, detect objects, understand the speech from the human, and infer goals from it, create, plan, and execute it. Let's look at ROS and then get deep into how Baxter with MIDCA does. So ROS, Robot Operating System. Don't be deceived by the word operating system. It's ROS is not an actual operating system, but it contains software libraries which can be used to build a robotic applications. So it's a robotic middleware. So let me just introduce to the concepts of two ROS node and ROS topic. Uh, they can come in handy for my next slides. So what a ROS node is, consider it is as an executable application, and a ROS topic is a communication between ROS nodes. So let's go deep in what MIDCA has, what MIDCA and ROS interface has. So we have an object detection node where object detection is performed. I mean, it recognizes objects and gives the real world coordinates of it. And the voice recognition node where we speech to text. And then we consider whole MIDCA as a node. And the Baxter grabbing node, which are the end effector functions to raise the arm to get to the location and such things. Let's see how communication goes between these nodes. We have the object detection nodes, and here the object underscore position is a topic. So what the object detection node does is it recognizes the objects and gets the real world coordinates and sends it to the MIDCA. And similarly, the voice recognition node uh, from the human, I mean, transforms it into the text and then sends it to the MIDCA. While MIDCA does a lot of things, uh, it perceives the state, I mean, interprets the goal, and then plans, executes, and then gives the end effect or the task. Similar to going to certain location, I mean, grabbing the object, raising its hand, releasing, similar kind of things. And the MIDCA feedback is actually a topic which contains whether the action is done or not. Yeah. So let's see how MIDCA handles all these topics. So we have this concept of handlers in MIDCA. What they does. I mean, they asynchronously communicate uh, with ROS. I mean, they synchronously communicate with ROS, gets the messages from those object detection nodes and the voice recognition nodes. So we have three kinds of handlers here: object location handler, utterance handler, and feedback handler. So object location handler gets the real world coordinates of an object, and then during the perceive phase, those from those coordinates we actually get the predicates, and during the perceive phase they are actually given a states. I mean, the states are updated. And for the utterance handler, we get the text representation of it, and during the interpret phase we infer goals from that text, and the feedback handler is to get the whether the action is done or not, and it's done during act phase. So what we have for the experiment, so we have 3 to 4 different colored blocks. We have the Baxter robot, and I'd like to talk about two different functionality apart from MIDCA, which we have done here in order to get going. So the one which is speech to text, and the other one is object detection. So let's get started with speech to text. We use pocket Sphinx to train the model on a set of different utterances, and then we convert into the predicate format in the interpret phase. So suppose if you have an example of stack the blue block on the red block, so they were converted into on of blue underscore block comma red underscore block in the interpret phase. And in the object detection, so we have used Asus Extion Pro 3D live camera, which is a depth camera, in order to detect the objects. Though the Baxter has three cameras, we choose to use the depth camera in order to get the XYZ coordinates, because from a 2D camera we could only get XY coordinates. So what we have done a whole lot of things here. So in order to detect the blocks which you have, which you can see blue, red, and green. So we have done different tasks in order to get that. So firstly, the filtering. As you can see in the diagram here, you can see the whole lot of room space. So we just limited it to the table and the blocks. And downsample the pixels. This is done because to improve the efficiency in calculations in the computations. So, and then identifying the plane and then removing the plane from the picture. And finally identifying the blocks based on their color. So that's what it goes into this. Finally, let's look at a video. So we can, Baxter in the blocks world domain, given a speech given a speech, it stacks the blue block on the red block. It can stack up to 3 high. So so I'm going to conclude this and future ideas. So so abstraction, we can actually interface a robot with MIDCA. It's not just limited to the Baxter robot, any robot of its kind, like a turtle bot or something like that. And we also have a simulator, and through the simulator, if it doesn't have a physical robot, we could also work on it through a simulator. So what are our future ideas? So Baxter robot to be doing in a blocks world domain, but then we would also want to expand it to setting the table for a restaurant, or making it work when 2 or more blocks of same color exist. So those are my future ideas. And yeah, yep, and that's it. Thank you.